Hello everyone. In this video, we will be talking about classes and objects in Java. Here's a list of topics that we will be going over. First we have objects, then we have classes, then we have keywords, methods, scope, references, and to finish it off, we'll do some example questions. When writing a code in Java, there's one thing involved that's either being created or changed. This is what we call an object. Programs are created to change these objects, which we will discuss later in detail. Objects are characterized by their behavior and their state. Objects are made to correspond and represent a real-world object. I will show an example after this. In Java, objects are referenced using a variable which we call an object reference. Picture a library, and you want to write a code to basically picture your library. We will have two objects referenced, book and list of books. The object book represents a book within the library, whereas list of book represents the list of books. Programs such as getAuthor and getTitle are used to describe the state of the object book. A class is a software blueprint used for the implementation of objects of a given type. Inside these classes, there is a single instance which we learned is called an object. The state of an object is maintained within data fields or instance variables provided by the class. Inside of the class, there are methods which provide the behaviors of the object and the operations that manipulate the object. Combining an object's data and methods into a single unit is called encapsulation. Here's an example of a class. The first line represents the beginning of the class. The second line represents an example of an instance variable. The third line represents an object, and the fourth line closes the class. There are four keywords that we will be looking over today: public, private, static, and this. Right now we'll look at the first three, and we'll look at this later. The word public preceding the class means it is usable by all pieces of code that are outside the class. This also goes for methods in a similar fashion. Private variables and private methods are only accessible by methods within the same class. And static means that the memory allocation happens only once. So a static variable is shared by all instances of the class. The next topic is methods. This topic has a little bit more to it than the other ones that we've done so far. To begin, all methods look like the following as far as the header goes. Public, void, example, int num is our example. Each spot represents a specific thing. So the first spot is the access specifier, so public or private. The second is the return type, so void means nothing, but then you could also have string, int, etc. Third and fourth part are the name of the method and the parameter list. The following are types of methods: accessors, mutators, constructors, and static methods. Constructors create objects within a class. They use the name of the class along with the parameter. So in our example, we have public example in the third line. That means it's an empty parameter, so an empty object. Unlike generic methods, they do not have a return type. Accessor methods access a class object without altering the object and return information. So this can be used with private instance variables. Ignore the red underline there. Mutator methods change the state of an object by modifying one of its instant variables, but it does not return anything. Static methods perform operations for the whole class, not its individual objects. An example of this would be the main method, which is used as a driver program to test other methods. Method overloading is when there are multiple methods in the same class or subclass that have the same name and different parameters. So here we see watch is used twice, even though it has different parameters. It's considered method overloading. The scope of a variable or method is the region in which it can be viewed or accessed. For example, a variable defined inside of a method which is called a local variable, can only be accessed within that method. These variables take precedence over instance variables. Another keyword that we didn't talk about before is this. An instance method is always called for a particular object. The object is an implicit parameter for the method and is referred to with the keyword this. The difference between references and primitives is the way that they are stored. Primitive data types are not affected by each other when stored, whereas references data types can have the same address. This means that when you change one object with the same address as another object, both of them change. An uninitialized variable is called a null reference or null pointer. Attempting to use an instance method with a null variable may result with null pointer exception. The header of the method defines the parameters. At the creation of the method, these are known as formal parameters, which are placeholders for the actual parameters that will be used later. Now we will begin the multiple choice questions on classes and objects. 1 through 3 refer to this code. Which of the following is a false statement about the methods? The answer would be D, because there are only two constructors. We see public time right here, and then we see public time again here. No other times does it appear with the name of the class and no return type. Number 2, which of the following represents correct implementation code for the constructor with parameters? So that would be this one. The parameters have H, M, and S. So the answer would be B, setting the instance variables equal to the numbers in the parameters, or whatever variable comes into the parameters. Which of the following are correct replacements for method body? Replacement 3 will automatically print the time. Replacement 2 and replacement 1 will not work because you cannot print objects and you cannot access instance variables. So the answer would be C. Moving on to number 4, which statement about parameters is false? C, two overloaded methods in the same class must have parameters with different names. That is false. Number 5, which of the following correctly constructs a date object in a client class? We see, as we look through, we look for the one with the correct constructor with the date. So you want to make an object D, so you need to use the object that has month, date, and year in the parameters. A does not have the name of the class. C does also not have the name of the class. D is not initialized as an object when you put it on separate lines. And here it does not say new, so the only correct answer would be B. Which of the following will cause an error message? 1 will not cause an error message. You're creating 2 objects, fine. Number 2 will also not cause an error message. 3 will cause an error message, so your answer would be C. Number 7, which of the following subsequent code segments will cause an error? The only one here that will cause an error is E, because you are trying to access a instance variable without using, well, parentheses in this case, and you can't access a private variable. For number 8, which of the following could be used as implementation code? All 3 of them can, because you can, within a code, you can access the instance variables. You can also use the parentheses, and this is the keyword that we have learned will allow this to be true. Number 9, which of the following is a correct replacement for code to get birth date? 1 will work because it uses the correct, it asks for the month, date, year. So when you read the user input, it will automatically assign those variables to M, D, and Y. 2 will not work because you are trying to create a new date and then also trying to access other parts of the class. And then 3 will also not work because you cannot use a code to set a variable equal to something. Int birthdate.month is cannot equal a new variable. Number 10, a method in a client program for the date has this declaration, known as D1. The same method now creates a second object D2 that is an exact copy D1 refers to. Which of the following code segments will not do this correctly? The answer would be A, segment 1, because it will cause D2 to refer to the same object, which is not what was required. The keyword new must be used to create a new object. You would need to initialize D2 before you could set it equal to D1. Number 11, which will be true after executing this code? The answer would be C, recent date is a null reference because it recalls a method that does not replace the object reference, so it will remain null. Number 12, which of the following methods in the frog class is the best candidate for being static method? The answer would be B, because the pond temperature is not affected by different frogs, so you would want that to remain the same. What will be the output by this program? You would get E, as you start out with 6 and 3. Then you would get X and Y to be 9 and 27. When you print A and B, first you print the code, and then you print A and B. A and B are not changed, so they remain as 6 and 3. So 9 and 27 are what come out of the code, 6 and 3 are what you begin with, so the answer would be E. Questions 14 through 17 refer to the code on the left, so the method reduce is not a public method because the reduced method will be only used in the implementation of the instance methods of the rational class. Number 15, the constructors in the rational class allow initialization of rational objects in several different ways. Which of the following will cause an error? Rational R4 equals new rational 3.5 will cause an error because none of the constructors in the rational class takes a real valued parameter. Thus, the answer in choice D will need to be converted to an integer. Number 16, which of the following is the correct replacement for more code? The answer would be E, as the other ones would cause an error. For example, you cannot, for answer choice A, you do not have a new, so you are just writing a code that would cause an error. B does not return anything, you have to initialize it first. C would just give you an error because reduce is not attached to anything. And D, rational.reduce in the second line would cause an error because you're using the class and not a specific variable. Number 17, which of the following will cause a compile time error? The answer would be D. The plus method of the rational class can only be invoked by rational objects. Since n is an integer, the statement in choice D will cause an error. 18 through 20 refer to the temperature class on the right, so you can pause to go back to this. A client method contains this code segment. Which of the following is true following the execution of this segment? The answer would be B, because this is an example of aliasing. The keyword new is used just once, which means that just one object is constructed. Number 19. which is the best replacement for code to construct? The answer would be E, because after looking at the choices, notice that is valid temp is a static method for the temperature class, which means that it should be invoked with the class name temperature, as in choice E. The method should not be invoked with T, a temperature object, as done in choice C. Number 20. Which of the following correctly replaces more codes so that the post condition is achieved? There are multiple that will do this. 1 and 2 will both do it, as number 1 has the equation for Fahrenheit to Celsius, and Celsius to Fahrenheit, my bad. And 2 uses the code to do it. Number 3 will not, because this cannot be equal to a certain number. Number 21. If the input value for n is 3, what screen output will this program subsequently produce? You would get answer A, because the 3 only prints 0 no matter what value you put in for n. It just increases the number of time that it's printed. Count is never initialized, never changed from 0. Number 22. Just before exiting this program, what are objects of x, y, and a respectively? The answer would be A, 9, 9, and 9. Number 23. Just before the end of execution of this program, what are the values of x, y, and temp respectively? You would get C, 6, 8, and undefined, as temp is never defined. And yes, that's it.